Based on your experience, what do you think the most underrated skill is for an engineer who wants to succeed in bridge design?
That's an interesting question because I think you're going to get lots of different answers from different people's perspectives. I think for me, in my opinion, the most underrated skill is understanding how things get built. Bridges are typically long and over complex topography or geology, and you've got water features that you might be crossing or roads that you're crossing or whatever.
What does it take to design a bridge that spans vast distances and withstands the relentless forces of time, nature, and daily use? It's the mastery of materials, visionary design, or is it the seamless collaboration of engineering minds? In this episode, we're going to be speaking with Shane Brown, a senior engineer at Parametrix, about essential skills and material considerations to balance safety, aesthetics, and the cost of bridge design. He's also going to be sharing his insights from his extensive career and how he approaches the complexities that come with designing enduring structures meant to serve for generations. I'm your co-host, Rachel Holland.
And I'm your co-host, Matt McCardle, and this is the Structural Engineering Channel. Before we get started, here's a quick word from our sponsor for today's episode, Parametrix.
Parametrix helps their clients imagine what's possible. Whether it's resilient infrastructure, livable communities, or habitat restoration, they partner with clients to create vibrant, sustainable communities and restore the health of the planet for generations to come. As a 100% employee-owned company, their people have a vested interest in strong performance and exceptional client service. Interested in becoming an employee owner at Parametrix? Learn more at www.parametrix.com. Let's create tomorrow together.
Shane, thanks so much for joining us today. Can you tell us a little bit about yourself and how your journey in structural engineering led to your current role at Parametrix?
Yes, and thank you for having me. So, I'm a senior structural engineer at Parametrix. I primarily focus on bridges. I get a little bit of experience dabbling in the building world from time to time with our water infrastructure projects that we work on, whether it's a pump station or a treatment plant. But most of my focus is primarily transportation infrastructure, bridges, retaining walls, and culverts, and so on. What kind of got me started in my career for structural engineering is it's actually, I think everybody has a different story on their path, but my particular path started as I thought I was going to be an architect. I started taking classes for architectural drafting at Lane Community College, and at the time I thought that was what makes you an architect. I didn't know that that's not what makes you an architect. But halfway through that associate's degree, I applied for a job that was posted on the bulletin board at the school for this precast concrete plant, and I went ahead and applied for the job and got hired on the spot. At the time, I knew absolutely nothing about precast concrete and very little about engineering, but I had a solid start on drafting with my Associates of Applied Science degree. And I also did it in high school, which kind of led me to the path of pursuing that after high school. When I got started at that job at that precast concrete plant, I immediately was on really cool projects. I was working on football stadiums, parking garages, buildings, and bridges, and it was all to provide the structural precast concrete elements for those structures to be constructed. But a lot of the times things are also designed by the fabricators too. So it was working directly with the engineers at that company where I got exposed to what engineering is. And I saw what they do, and I got really excited and got very interested in becoming a structural engineer at that moment. And actually I had a really good mentor there. And one day when he was signing plans and calcs at the end of the project and we were about ready to issue it for construction, I just kind of looked over at Keith, and Keith Kaufman is who I'm talking about, Dr. Keith Kaufman. And I told Keith, I was like, hey, Keith, I think I could do your job. And he looked back at me and he said, Shane, I think you got what it takes. I think you should go to school for engineering. So that was really the start of me pursuing a career in structural engineering. Fast forward, I finished my degree in civil engineering, and I was working still at the plant. So I worked full time and went to school full time. crazy. I don't know how I did it, but I did it. I worked really hard. And when I was coming out, I was looking for what are the other opportunities for me outside of working at the precast concrete plant. I went to a career fair. At the career fair, Parametrix was there. The I ran into a person, Steve Osaka, and I showed him my resume, and instantly Steve was really enthusiastic about me coming to Parametrics, and he literally told me, "We are going to hire you. I will set up an interview." So I had many interviews with a lot of companies, but ultimately I felt a gravitational pull towards Parametrics due to that initial interaction I had with Steve and his I felt valued with the way he expressed his interest in me coming to Parametrics. I also really appreciated the fact that Parametrics was a 100% employee-owned firm. I liked that there was an opportunity to, have ownership in the company. And then Parametrics is also very focused on environmental sustainability. And, who doesn't want to be thinking about the future for our planet, right? So I really like that about Parametrics. And then I also saw that the potential to earn my structural engineering license. Steve Osaka was a structural engineer who I was talking to, still is a structural engineer. But it was that ability to see that there's a career path for me and the ability to achieve my structural engineering license with the right mentorship. So I joined Parametrics in let's see here, 2007, sorry. In 2007, I joined Parametrics. I've been here for 17 plus years now. I started as what was called an engineer 2 and gradually worked my way up through the ranks to become a senior engineer. I earned my professional engineering license, and then 4 years later, earned my structural engineering license, which was my career goal. And then over the time, my duties have kind of progressed throughout my career. I've worked on, early on, I focused a lot on trying to get the experience I needed to, pass the SE exam and so on. But after I achieved that, my career started developing more into mentoring junior staff, pursuing the work instead of just waiting for the work to come to me and do it. So a lot of it started to turn more into project management and also client relationships and marketing. I still do all the technical work. So that's the beauty is I get to do both. I enjoy the people aspect of project management and that ability to network with the clients and get to know more about the project at a very high level too, and not just the task focused piece.
That's awesome. I always feel like when people start at a certain company and then stay there through their career, it's just like a good insight into the type of company that you work for. So that's always a fun story to hear.
Yeah. And we're fortunate because in our bridge and structures group within the company, we've got several long-term people that have been with the company. So it's great. Yeah.
Awesome.
So.
And then just because I'm curious, where did you go for your degree?
Yeah, so thanks. I went to Oregon State. I got a bachelor's in science and civil engineering. I did not pursue the master's degree. I was really close to pursuing a master's degree, but it's kind of interesting because when you are coming out of school, most of your professors say, yes, go get your master's degree, go get your master's degree. And I had an offer from Purdue to go do so. But I was also a family guy. I had kids while in school. So my wife and I got married while we were in school. So I felt like I needed to find this balance. Do I go enter the workforce, or do I continue to pursue that higher education? One of the things that kind of stopped me from going to get my master's degree was a conversation I had with Dr. Higgins at Oregon State University. And he told me that I asked him about, hey, should I go do this? He was like, well, Shane, you're a really smart guy. Right now, companies are hiring. If I was you, I'd go make 50,000 instead of spend 50,000. So, no other professor told me that, but I thought it was kind of an interesting conversation, which ultimately led to me saying, okay, I think I might enter the work world. And I always kept it as an idea to go back for my master's, but ultimately I didn't go do that. But I also self-study a lot. And so I found that what I learned in that first degree, the bachelor's of science degree, is I learned how I can study on my own. and teach myself. And then also with the right mentorship, I was still able to, achieve my ultimate goal of becoming a structural engineer.
Yeah, that's awesome. Oh, I had a follow up. I wanted to ask, since I do mainly buildings for structural engineering, how did you choose bridges over or buildings? How did you end up making that the career decision, or did you even make that decision?
Yeah, great question. When I was coming out of school, I had experience at the precast plant working on both bridges and building projects. So I was really interested in anything that was structural. When it came out though, the it just felt like there was more opportunities in the bridge and community at the time. And so when I started at Parametrix, I do work on building projects from time to time, just not as much. Usually the building projects that I'm working on are for our water infrastructure, like treatment plants or pump stations, to supply water or pump water around or whatever. But most of my focus is in bridges. I think a lot of what led me to bridges, though, is my early mentorship that I had, where Dr. Keith Kaufman, who was at the concrete plant that I was working at, and also an adjunct professor at Oregon State University, teaching pre-stress concrete design. He was really adamant that he was going to make me a bridge engineer. and and so although I still kind of was really interested in both bridges and buildings, but I think that I just naturally kind of gravitated towards it because I had a strong grasp of it already. And so it kind of was a good start to my career.
Yeah. What about, when you kind of, made that decision and you kind of went with bridges, based on your experience, what do you think like the most underrated skill is for an engineer who wants to succeed in bridge design?
Yeah, that's an interesting question because I think you're going to get lots of different answers from different people's perspectives. I think for me, in my opinion, the most underrated skill is understanding how things get built. Bridges are typically long and over complex topography or geology, and you've got water features that you might be crossing or roads that you're crossing or whatever. You're usually confined in space or maybe difficult to access to get to the site. So having an understanding of how the contractor can actually build the bridge that you're designing is extremely necessary in our profession. So building bridges take really large equipment. We've got big cranes, we've got if you're going to do a drilled shaft, you've got lots of big equipment associated with those types of foundations. Just having an understanding of how it gets built and what the contractor needs, what room they need to go ahead and have all their equipment on site. Do they need access work bridges? Do they need a detour bridge? There's so many things involved with bridge construction that just having an understanding of how it gets constructed is fundamental for any bridge engineer to be effective. So,
and Shane, would you say that you get that just from experience, or is that something that you learned in school?
Very good question. You don't really learn that stuff in school.
Yeah, I was going to say, I don't feel like maybe a little bit, but
yeah. So I mean, in school, you learn, okay, how to analyze the loads on a structure and how to design the element to resist the loads, but you don't really learn about how it gets built. And so that I think really more comes from your experience outside of school. And if you want my suggestion for anybody that's in school, go tour a construction site. Go ask the contractor if you could get a tour. Go talk to the engineering firm that designed it and see if they can give you a tour. If you're just trying to figure out what things look like and how it gets built, go to the job site. That's the most important thing you can do.
And does Parametrix like put value on that? Like, do you guys send your newer engineers out to job sites to learn all that stuff? Great.
Absolutely. When I first came to Parametrix, one of my first projects was there were 7 bridges that we were doing for a local agency. We had already done the design, and the first it was put out in phases, and the first phase was going to be 4 bridges get built in one season, and then the last 3 bridges would get built the following season. So my first project was to go out and do the inspections during construction. And that was what better way to get that on-site experience is to be out there inspecting and observing what the contractor's doing and making sure they're following the plans and doing the best you can to deal with any issues that come up.
Yeah.
So
Can you walk us through a bridge project that you've worked on and maybe share some of the challenges that you had to deal with?
sure. So, well, each bridge project has its own challenges for sure. One particular project that I recently completed will construct a system to system interchange. And what that is you're connecting two highways together in a way that traffic doesn't have to come to a stop. It can free flow and change from one highway to the other. So that oftentimes comes with braided ramps. So, when you look at these big system interchanges, you see big flyovers, curved bridges, and things crossing over each other and so on. Those are all called braided ramps. And those big curved bridges are usually called, usually referred to as flyover bridges. So on this particular project, I was tasked with managing the team for the design, but also serving as the engineer of record for one of the curved bridges. The challenges associated with that project there's plenty of them. You have vertical challenges that you have to constantly be checking to make sure if you change one parameter on your bridge, does it affect the other bridge that might be crossing over or under your bridge? Because remember, you got to maintain a clearance between these so that vehicles can pass under, and you don't have a problem with the vehicles obstructing your bridge or hitting your bridge. There's you got a lot of coordination with the roadway design team, because anything that you need to propose to change the profile, it needs to be coordinated with them. There's challenges associated with right-of-way, making sure that you're staying within right-of-way limits. Wetlands, you got to make sure that you're not having negative impacts on wetlands and so on. There's many different challenges that come up with different projects, but this particular one had pretty much all of them. So each one of them has its own unique way to resolve them, but you have to just work with the team to figure out what's the best solution.
What about when you design, you just talked about like all these different things you have to think about, but when you design a bridge, like how do you go about selecting what type of bridge is going to be built? And then like, are there different factors you're considering, separate from the ones that you sort of just mentioned with the clearances and everything else?
Oh yeah, great question. So when we select a bridge, it's usually done by a study that you do for feasible bridge types to fit the site. It's documented in what's called a type size location report. Commonly, we just call it a TSNO report. We like our acronyms in the industry, right? So through that type size location report, you're going to, again, evaluate feasible bridge types for the site. The feasible bridge types come with experience, but the factors that often are being evaluated are factors such as some of those that I already talked about, but I'll kind of reiterate some of those, like geography and topography. What is it that you're crossing? Are you going to be crossing a water feature like a river, a lake, a bay, or whatever? Or are you crossing a railroad or a highway? You also have to have an idea about the soil types. You need to know if the soils are going to be capable of withstanding large loads or not. If the soils aren't capable of withstanding really large loads, that can influence your span length capabilities and what you're going to have to do for the structure. Again, understanding the clearance requirements. If you're spanning over a river, you're going to need to know the hydraulics of the river. What are the water surface elevations during the different flood events for your particular site? If you're over a road or a highway, there's different vertical clearance requirements associated with those crossings also. Traffic volumes. We need to know how many lanes to put on the bridge, and that all comes down to how much traffic's going to be crossing the bridge. But it's important to not just think about the volume of traffic that day, but future traffic. So you always want to plan for the future traffic volumes. Other factors are environmental factors. I kind of touched on wetlands, but there's also endangered species. Do you have to pay attention to those? Maybe you can't put a foundation in the river for that reason. There's also neighboring communities and airports that might be nearby. Are they going to be impacted by the construction? These are all factors, environmental factors that you have to consider when you're choosing a bridge. Of course, then there's aesthetics. The owner may desire a signature bridge per se. Maybe not. Maybe a common bridge type is fine, but those are factors that have to be weighed into feasible bridge types for your crossing. And of course, cost. Cost is always something to be considered. And that factor really comes down to understanding what the budget is and what the owner can work with to build the bridge.
Wow.
So those are just some of the big factors that go into this. When we select our bridge type, though, we look at all these factors that are decided that are prudent for a particular project, and we weigh how that bridge performs for that different factor. And then, based on the outcome of what we see through that selection process, it usually helps guide us to selecting what is the right bridge type.
Yeah, that's awesome. It's like that's what I appreciate about engineering. There's something that you see that's out there in the built environment, and you don't necessarily see all the things that go into it, the problems that need to be solved. For me, coming at it from a building engineering perspective, uh, follow-up question to Rachel's, because you mentioned some of the designs. How involved is the architect, or is there even an architect for most of these projects? Just because, my perspective.
That depends on the project. So many bridge design projects, your common bridges, like girder type bridges, your everyday bridge that you kind of see when you're driving on the road, oftentimes don't have an architect involved. But it also depends on the client and what's the expectations for the project. Some state DOTs actually have an architect that's involved in every project and has a little say on how things should look for the bridge. Others don't. But again, it comes down to the project and what's desired. So if you're putting out like a signature bridge, say a Golden Gate per se,
Yeah.
you're gonna probably have an architect involved. Pedestrian bridges in high profile areas oftentimes have an architect involved to help control the aesthetics of the structure.
And you also mentioned, I know earlier you mentioned mentorship was played a big part in your career. How has mentoring others and being mentored influenced your own career?
Yeah, mentoring is extremely important for anybody in their career. I've been fortunate, like I said, to have really good mentorship when I first got started. But for me, I really enjoy mentoring because it gives me the opportunity to, first of all, solidify what I think I know. If you can teach it, then you know it.
Yeah.
That's, a good general rule of thumb, right? But also to see the growth and the emerging professionals coming up. When you mentor someone and you see how they're growing and changing in their capabilities, it's satisfying to see that. So when I get asked a question, I usually get really excited when someone comes and asks for help from me because I have the opportunity to, I guess, play professor. I I commonly will bust out a sketch and give a full lecture, give way more than what they really asked for. um but my hope is that they got more than what they asked for, and that they feel confident in what they're doing when we're finished with our discussion. And really, that it just builds a good relationship with those that you work with too. So I think that it's the opportunity to build that relationship, see their growth, and also, confirm that I think I know what I know. If you can teach it, then you know it, kind of thing. And oftentimes, I like that after I've mentored someone, I know they know how to do it, which is great. But a lot of times, I'll ask them if to help someone else out, to help them start to do the same thing.
Yeah, I feel like mentorship and, like if we've been lucky enough to have that in our younger professional years, I mean, even now still, but then also being able to like return that to the people that are newer in their career. Engineering, like our profession is just so collaborative, like it takes all of those conversations and working together to create the projects that we do.
Absolutely.
Yeah.
Absolutely. And that's the best way you can kind of pay your previous mentors, is to pay it forward, right?
For
So
sure.
that's, I mean, what better way to repay them except to share the knowledge?
Yeah. What about, can you share a like a memorable experience when collaboration was essential for dealing with a major challenge that you've had in your career?
Recently I just was pulled into a project that they had a schedule issue. They had a 5-span pedestrian bridge that they needed to have designed, and it needed to be completed in 10 weeks. That is an extremely aggressive schedule for this particular project, because normally it takes about double that to have your design complete. But to face that challenge head on, the first thing we did was I assembled a team And when I assembled that team was about twice the size of what we would typically use for a bridge of this magnitude. But the important part about assembling that team is we assembled our work plan on how we were going to tackle this project and get it done on time. We all were actively figuring out whose role is what. How does their role affect the other person's role? We established our schedule. We assigned who was going to be QC or quality control checking and stuff, the design. So that upfront collaboration with the team as a whole led to a very successful outcome for the project. We delivered it on time. We delivered a good quality design. We didn't sacrifice quality ever, because you never want to do that. You got to make sure that everything's checked all the way throughout. So that collaboration up front with the team to establish, what is our schedule, who's doing what, when it needs to be done by, led to like very successful collaboration for the project as a whole, because everybody was engaged throughout the project. No one was wondering who's doing what, when, and where. Everybody knew exactly what was going on. So that, I think the process that helped with that collaboration was establishing that work plan together as a team and having that buy-in from the team on how we're going to do it together.
So did you guys like use what you learned on that project, and are you now doing those in 10 weeks instead of 20, just moving forward as a general standard?
Yeah. My hope is that we don't do that all the time.
All right.
But I do think there were definitely lessons learned on that collaboration up front to develop your work plan as a team instead of an individual develop the work plan and push the information out to the group. I think it was the real fundamental piece there was to do it together. And then everybody up front agrees that this is what they'll do and makes it happen. So
that's great.
And Parametrix, they have an employee ownership model, right?
yes.
How does that affect maybe the project management and the client service with that type of ownership model?
Yeah, so in my opinion, I think that for me, ownership in the company is an awesome thing. So, but how the company performs is really based on how the clients perceive, right? So client satisfaction is like paramount for our industry, right? We need to have good client satisfaction. By being an employee owner, I feel empowered to make that happen. So as a project manager, recognizing that, client satisfaction is the utmost important thing that we need to do to help succeed or be successful in the company, and recognizing that it automatically or directly impacts, the money I get. Let's be honest. I mean, that's what ownership provides is, a financial gain. There's a direct correlation there. I mean, when you have ownership in the company, you feel responsible to make sure it succeeds. In order to make sure it succeeds, you got to have clients that are satisfied with the work that you're providing. So
yeah, I feel like that comes, it's both ways too, right? Like it affects how you spend money. It affects how you use your time. It affects like a lot of different things like that, because you're making those decisions based on your end result too, not just the
absolutely
companies.
Yep. And ultimately everybody else in the company, right? I want to make sure everybody's getting their share.
Totally.
So, and that's one thing that's really kind of nice about Parametrix is we hear about employee owned companies, but everybody in the company owns part of the company. Whereas there's other models out there that not everybody owns a piece of the company. It might be 100% employee owned, but not everybody in the company owns a piece of the company. So I think that's one thing that's kind of special about our model is everybody owns a piece of the company. And so everybody feels that sense of ownership.
That's awesome. What about the way that you've described it so far, bridge design, it often requires some tough trade-offs with all the different things that you've been talking about in terms of challenges and things you have to consider. Is there an example you can share where you had to make a hard decision in order to balance like safety, cost, aesthetics, all the different things?
Yeah. So first of all, we never compromise safety.
Well, that's good.
as
Just to
structural
clarify, right?
engineers, yeah,
Yeah.
safety is paramount. That's our number one goal, right? Public safety, for everybody. So we don't really compromise on safety. With that left, you're talking about aesthetics and cost, right? So that kind of those two factors kind of come down to what the owner wants, ideally, or desires to have as an outcome for the project. But again, like we never sacrifice safety. So I've yet to have an actual situation come up where I have to weigh safety versus cost or safety versus aesthetics.
What about on that same line? There's a big conversation about like, code minimums versus like performance and like, after an event, like, are those discussions happening where it's like you're not sacrificing safety, but maybe like the level of performance, is that going to be client, how far above the code standards they want to go and stuff like that? I mean, that's part of those decisions, right?
So yes, that's true. So codes, they provide the minimum standard that you have to provide, right? So you can always go above and beyond the code. You can't go below the code. So with that said, like if we talk about seismic design as an example, seismic design, many agencies actually have requirements that are above and beyond the code minimum for your seismic design. I live in Oregon, and we have the Cascadia subduction zone that is a big conversation in our state, and Washington also. But so like Oregon DOT has special additional seismic requirements that you have to actually satisfy that's above and beyond what the code does. In the code, we're commonly looking at strength issues, and Oregon will go further and start looking at service issues, like how is the bridge going to remain serviceable after the event? And so oftentimes it is very much comes down to owners' requirements too of what they ultimately want to have for that project.
And what final piece of advice can you give structural engineers that are interested in specializing in bridge design and making a lasting impact in the field?
Final piece of advice. I think that the biggest maybe thing I would advise is to, I'd say, get involved in the community. So the bridge community, there's lots of organizations out there that offer seminars and conferences to attend. They provide an opportunity to stay up to date on the latest technologies and also network, which is an extremely important part of your career. So getting involved in the community by going to the seminars and conferences is going to be extremely valuable for you. Also, by attending those, maybe after you have a couple years of experience or you think you've got something that's worth talking about, submit an abstract, present at them. It'll do wonders for your career.
Yeah, that's awesome. Great advice. I know being in part with the community, especially the engineering community, it's a small community. Even if you're from different states, you'll eventually just run into those same people that are working at those companies or those projects. And yeah, you'll be surprised how far that takes you in terms of your career.
Yeah, you never know who your next client's going to be or your next teaming partner is going to be, or your next new employee. So,
Yeah,
I mean, it's a great way to network is by getting involved with the community, going to those conferences and seminars.
Yeah.
it's awesome. Shane, thanks so much for sharing all of your experience. I know for me, I definitely enjoyed that. I've always wondered, what would a career in bridge engineering would have been like if I went that route for me. So I definitely appreciate it.
Yeah.
Well, I
Thanks,
had a
Shane.
great time. Thank you very much.
I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, wish you the best in all of your structural engineering endeavors.